Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So today I'm going to talk about area of a curve entirely below the x-axis, okay? So like I always say, make sure you review previous video and make sure as well that you understand those concepts before moving on, because the next concept is built on previous concepts. Before I proceed, please don't forget to like, share, and subscribe. And if you have any questions, do let me know. Send me an email. And if you've not clicked the notification bell, please do so that when I post new videos, you'll be the first person to know. All right. So quickly, in the previous one, we talked about area of a curve entirely above the x-axis. Now we're going to talk about area of the curve entirely below the x-axis. Okay. So always remember that the area is from the curve or the line to the x-axis. And it's better to draw the curve to see the shaded area, although it's not compulsory, but it's important, okay? So because I'm aware some students will take notes, I'm going to write this down. So always remember the area is from the curve or line to the x-axis. Okay? And like I always say, make sure that you try to draw the curve so that you can see the shaded area. It's not compulsory. I always tell students it's not compulsory, but it's important to do so, okay? So drawing the curve. All right. So drawing the curve to see the shaded area is not compulsory, but important. All right. So let's just get straight into it. I'm going to solve an example, but before I do that, let me write down the 5 steps to solving this, or the 5 rules, depending on how you want to call it. So the first thing is that the area must be positive, all right? Same thing, similar to what we talked about the last time. The area must be positive. And if negative, you have to ignore the negative sign. Number 2, first thing you have to do then is that when you want to start, you have to integrate the function as normal. You can use any of the 16 integration rules we talked about. That was the reason why I said you must be very conversant and very comfortable with integrating before you come to this point, okay? So firstly, you have to integrate. So you have to integrate the function as normal using any of the previously discussed rules. Number 3, okay? Then after you've integrated, you have to then substitute the upper limit into the integral expression. So from step 2 to get a value y1. So similar to what we did above the x-axis, where you substitute the upper limit, then you substitute the lower limit, then you subtract. So step 3 to 5 is basically the same thing. So then you what? Substitute the upper limit into the integral expression. From step 2. And have a value for y. So we call this value, let's call it y1, all right? So that it'll be easy for me to explain, all right? So that I can differentiate step 3 from step 4. And after you substituted the upper limit, then you do exactly the same thing and you substitute the lower limit. And this time you will call it y2. So you're going to substitute the lower limit into the integral expression. From step 2. And you're going to have a value called y2. Then when you're done with that, step 5, you then subtract step 4 from step 3 to give the area. All right? Then you then subtract step 4 from step 3 to give the area. So therefore, what I'm saying that the area is going to be called y1 minus what? y2. So that's what you do. And that's what will give you the area. That'll be y1 minus y2. So basically, it must be positive, and if it's negative, you have to ignore the negative sign. You integrate the function as normal. You substitute the upper limit, then you substitute the lower limit, then you now subtract, and you now get the answer for that. All right. Let us pick an example here, okay? So I'll just pick one example here. Then the next video, I'm gonna solve more examples then. Is that okay? So let's assume we have this example. Number 1, let's say we're told to determine the area bounded by the curve y is equal to x squared minus 9, okay? With the x-axis, okay? Now, and we're looking at if the ordinates, in this case, let's say the ordinates are -1 and x is equal to 2. Okay? Okay? So now in this case, so just to remind you, okay, now because it is below, all right, because it is below, area must be positive. Now, because it's below the x-axis, the answer you will get will be negative, but you have to ignore the what? The negative sign. All right? So because you're doing this, the answer is going to be negative, but you have to ignore. So don't forget this part. You have to ignore the negative sign. So when we're going to solve this, you will see that the answer you get is negative because the area we're looking at is below the x-axis. So let's start. So step 1. So we're told, so step 1, we know that the area must be what? Area must be positive. So must be positive. So let's don't forget that. Area must be positive. And if you sketch this graph, x squared minus 9, the graph is going to look like this. Okay, like I always say in some of the exams, we'll give you the graph. Some of the exams, you have to sketch the graph yourself. So if you're not comfortable sketching, please go to my previous video series on sketching quadratic graphs or polynomials or linear graphs, and try as much as possible to understand that. So so if you draw x squared minus 9, it's going to cross the x-axis at minus 3 and plus 3. Okay? It's going to cross the x-axis at minus 3 and plus 3. But in this question, we're not interested in that. We're only interested between 2. So let's assume 2 is somewhere here. And we're interested with what? Minus 1. So let's assume minus 1 is here. So this is the only part of the curve they want you to find the area of this region here. Is this making sense? So this is the part they want you to find the area for that. So let's go. So step 2. So let's go to the step. What do we need to do? We need to integrate the function as normal using any of the previously discussed rules. So we have to integrate it using any of the previously discussed rules. So let us integrate this. So step 2. We're meant to integrate this function between 2 and minus 1. All right. So I'm just integrating x squared minus 9 between 2 and minus 1. So what do you do? So let's go. How do you integrate? So if you've not reviewed my video on how to integrate, please do so before you proceed here. So you add 1 to the power and you divide it by the new power. So it's going to be x. 1 plus 2 will give you 3 divided by 3 minus, when you integrate a constant, is going to give you 9x. Okay. So I have a video series on this. And then you're integrating between 2 and minus 1. Okay, so step 3. So step 3, I told you then, what do we need to do? We need to then substitute the upper limit into the expression to get a value y1. So we need to substitute the upper limit. The upper limit we have here is 2. So anywhere you see x, you put 2. So it's going to give you 2 raised to the power 3 divided by 3 minus 9, 2. All right. And this is going to give us minus 46 over 3. All right. Now the next part, you then step 4. You do the same thing, but this time you substitute the lower limit. So same thing, but we're told that we need to substitute the lower limit into the expression. Okay. So the lower limit we have here is minus 1. So it's going to be minus 1 cubed divided by 3 minus 9 minus 1. And when you solve this, it will give you 26 divided by what? 3. Now step 5. So step 5, the area is the answer from step 3 minus the answer from step 4. So y1 minus y2. So that means the answer from step 3, which was the y1, and the answer from step 4, which was the y2. So it's going to give us y1 minus y2. So it's going to give us minus 46 divided by 3 minus 26 over 3. And when you solve this, it is going to give you minus what? 24. But remember I told you that the area in step 1 must be positive. So you ignore the negative sign. So let's ignore the negative sign. Then instead of us having minus 24, the area for this is going to be what? 24 units squared. Okay? And that will be that for that. All right. So I think that will be that for this example. So basically, these are the 5 rules. The first thing you need to do is that you need to ignore the negative sign when you get an answer. You integrate the function, substitute the upper limit, substitute the lower limit, and you subtract each other. All right. So what I'm going to do is that I'm going to end this video here, but the next video, I'm going to solve more examples, okay? But always remember that when you integrate, it is from the what? From that line or the curve to the x-axis. It's going to give you the area from the line or the curve to the x-axis. And it's important to draw sometimes so that you can see the shaded region. It's not compulsory, but it's important so you can visualize what you're looking for. All right, so I'm going to see you in the next video. We're going to solve more examples. So it's important that you subscribe and click notification bell so that when I post the next video, you'll be the first person to know. All right, so I'll see you soon.